We think Dart is pretty cool, so we wanted to build something fun and unique to help teach people about this awesome programming language. So we built this. A command line audio player that we built using Dart FFI. We think this is pretty cool and wanted to share how this all works. Let's get started. We're going to look at what this experiment does before we dive into its inner workings. To do this, I'll launch our program via a terminal instance. After pressing enter, we'll begin to see immediate feedback that the program is working as we hear audio. On the top of the screen, we have the note and pattern data from our music file. On the bottom, we have the real-time waveform display. The render logic adapts as the terminal is resized, adjusting the pattern and waveform as necessary. Pressing any non-control key on the keyboard will cycle between real-time waveform and time-based waveform. Finally, to exit the program, we'll hit Control-C. Okay, so we now know what our experiment does. Let's look at how it works from an architectural perspective. Here's one way we can visualize the architecture from our experiment. Our main program is called player.dart. It's responsible for orchestrating the audio side, as well as managing features like rendering of the song pattern data, the song waveform data, as well as handling the terminal resize and so forth. This main program depends on a utility called Dart OpenMPT. Dart OpenMPT is responsible for brokering communication between the C and C++ side using what's called Dart FFI. It depends on something called lib.dart OpenMPT, which is a compiled C++ library that we created. Lib.dart OpenMPT contains two files, OpenMPT-CPP and SoundManager.cpp. OpenMPT-CPP is a program that's responsible for making sure our C++ functions are accessible using what's called the extern-C keyword. This is necessary because Dart FFI doesn't have the capability to expose functions directly from C++. Now, SoundManager is responsible for creating an instance of lib.openMPT and spinning up port audio. We'll go into a deep dive on how the audio stuff works under the hood in a future video, but in the meantime, OpenMPT is an open source library whose sole purpose is to generate music from our music file in the form of audio buffers. Port Audio is a cross-platform open source library that makes it easy to write audio apps, and it's what feeds that buffer data from OpenMPT to our operating system sound card. We now have a high-level understanding of how this experiment's architecture works. In the next video, we're going to focus on the C++ libraries and look at how the audio stuff works under the hood. Afterwards, we'll pop up to the Dart layer and review how we connect our C++ functions to Dart via FFI and explore how we draw the waveform data in real time. In the meantime, we put a link to the GitHub repo in the description below in case you want to look at the code. Thanks for watching. We would love to know what you think about this experiment. Please like and subscribe for more content from our labs team.